On October 4, 1957, the world's first artificial satellite was launched into orbit. After the successful orbiting of the Earth's first artificial Sputnik and the achievement of the first space velocity, Earth scientists were faced with the task of achieving the second space velocity. Achievement of the second space velocity was unsuccessful by the United States and the Soviet Union. The first country to launch a spacecraft toward the Moon was the Soviet Union. On January 2, 1959, the Vostok Luna launch vehicle was launched, which put the automatic interplanetary station Luna 1 on a flight path to the Moon. The station registered the Earth's external radiation belt, made the first direct measurements of solar wind parameters in the interplanetary space of the Moon and the Earth, passed 5,000 kilometers from the Moon, discovered the absence of its magnetic field, entered a heliocentric orbit around the Sun, becoming the first artificial planet. Pioneer 4 was launched on the 3rd of March, 1959 from Cape Canaveral and on the 4th of March flew 60,000 kilometers from the Moon at a speed of 7,230 kilometers per second. Pioneer 4 transmitted radiation data for 80 hours to a distance of 608,000 kilometers, and as a result no radiation was detected in the lunar vicinity. After the lunar flyby, Pioneer 4 entered a heliocentric orbit and became a satellite of the Sun. On September 14, 1959, Luna 2 reached the surface of the Moon for the first time in the world in the area of the Sea of Rain near the craters Restel, Archimedes, and Autolycus. The craft had no propulsion system of its own. Its scientific scintillation counters, Geiger counters, magnetometers, micrometeorite detectors. The second space velocity was exceeded for the first time. Luna 3 was launched on October 4, 1959. On October 7, 1959, two-thirds of the hemisphere, invisible from Earth, was imaged. The images were transmitted to Earth by radio. On July 28, 1964, the Ranger 7 spacecraft was launched. For the first time, detailed close-up telephotography of the Moon was made during the station's fall to the Moon. 4,300 images were transmitted, taken from a height of 2,000 kilometers to 440 meters in the northwestern region of the Sea of Clouds, which was named the Sea of Knowledge in honor of this event. On February 17, 1965, Ranger 8 was launched. A second detailed telemetry survey was conducted. 7,100 images were obtained from an altitude of 2,500 kilometers to 160 meters over the area of the Sea of Tranquility. On March 21, 1965, Ranger 9 was launched. The third detailed telephoto survey was conducted. Received 5,800 images from an altitude of 2,300 kilometers to 600 meters over the mountainous region of the lunar continent in the central part of the visible hemisphere, where observations from Earth suggested volcanic activity. Small craters surrounded by a dark halo were detected. The Soviet Zond 3 spacecraft photographed one-third of the Moon's backside, which remained unknown, resulting in the first complete map and globe of the Moon, with significant white spots near the poles. On January 31, 1966, the automatic interplanetary station Luna 9 was launched toward the Moon. The automatic station consisted of a two-part flyby unit and an automatic lunar station. The flyby unit consisted of a corrective braking propulsion unit Tu-5A with 4 control nozzles, fuel tank made of aluminum alloy in the form of Thor, a spherical oxidizer tank 90 centimeters in diameter, a pressurized compartment, a control system of 2 jettisonable hinged compartments of the acute orientation system, and a high-altitude radio altimeter. Luna 9 made the world's first soft landing on the surface of the Moon. The station established the hardness of the surface, the absence of a multi-meter layer of dust. The first television panoramas of the lunar landscape showing details of the surface were transmitted. The landing area of the station on a flat area in the ocean of storms was named the Moon Landing Plane. Luna 10 is the world's first artificial satellite of the Moon. For the first time, data on the general chemical composition of the Moon were obtained by the character of gamma radiation of its surface, made 460 revolutions around the Moon. In 1966, the United States launched Surveyor 1, an automatic interplanetary station, toward the Moon. The American spacecraft made a soft landing on the Moon and for 6 weeks transmitted images of the surface to Earth. A telephoto survey of the terrain near the landing point on the plane in the area of the Ocean of Storms, north of the Flemsteed crater, and studies of the mechanical, thermal and electrical properties of the soil were carried out. The first American artificial lunar satellite, Lunar Orbiter 1, was launched on August 10, 1966. The spacecraft successfully entered a parking orbit. The main task of Lunar Orbiter 1 was to map the surface of the Moon to determine the landing sites of manned Apollo spacecraft. The spacecraft was also tasked with detecting micrometeorites in the near-lunar environment, studying the radiation environment on the path of and near the Moon, and studying the gravitational field and physical properties of the satellite. After 4 days on August 14, Lunar Orbiter entered the Moon's orbit and started the mission program. A detailed photograph of the landing sites on the visible side was taken. Luna 11, the second Soviet artificial satellite of the Moon, studied gravitational fields and gamma rays, studied meteorite and radiation conditions near the Moon. Luna 12, third Soviet artificial satellite of the Moon. On December 21, 1966, a Molniya rocket was launched, which put Luna 13 on a flight path to the Moon. On December 24, 1966, the Luna 13 station made a soft landing on the surface of the Moon in the Ocean of Storms. The station was equipped with a soil pentrometer, a radiation density meter, and a dynamograph, which provided the first ever instrumental study of the density and strength of the surface layer of lunar soil, regolith. Lunar Orbiter -3 conducted detailed photography of the human landing sites on the visible side. The spacecraft collected photographic data from November 18 through November 25, 1966, and readout occurred through December 7, 1966. A total of 609 high-resolution and 208 medium-resolution frames were returned. Surveyor 3 surveyed surface properties on a plain in the Ocean of Storms southeast of Landsberg crater. Explorer 35 spacecraft studied interplanetary plasma, magnetic field, and X-ray radiation from the Sun from lunar orbit. Launched on July 19, 1967, Lunar Orbiter 5, NASA's Lunar Orbiter program, was launched in 1967 to map the surface of the Moon. The spacecraft successfully accomplished its goals, becoming the 5th and last American artificial lunar satellite of this series. One of the goals of the Lunar Orbiter 5 mission was to once again photograph 5 of the 8 possible landing sites of Apollo lunar modules already photographed by previous Lunar Orbiter missions. The program included imaging objects of scientific interest. Surveyor 5, launched on September 8, 1967. The landing was made on the slope of the Sea of Tranquility crater. After a successful landing, the spacecraft operated on the surface of the Moon for 2 weeks. It transmitted 19,049 images of the lunar panorama and space, studied the magnetic properties of the lunar surface, and analyzed the chemical composition of the lunar soil using an alpha reflectance analyzer. As a result, it was found that the soil at the landing site consists of basaltic rocks. Surveyor 6 was launched on November 7, 1967 and made a soft landing on the lunar surface in the Central Gulf on November 10, made the world's first liftoff from the lunar surface and moved to another point, conducted chemical analysis of soil samples, and transmitted an image of the lunar surface to Earth.
On January 6, 1968, SC-7 was launched by the Atlas-Centaur combination that had performed in the 6 preceding Surveyor missions.
Surveyor 7 launched on January 7, 1968 and landed on January 10, 25 kilometers north of Tycho crater. Landing on the Moon for the first time performed in the mountainous continental region, in the southern hemisphere. Based on the results, the Surveyor 7 spacecraft transmitted 21,091 images of the lunar surface to Earth. Luna 14, the fourth Soviet artificial satellite of the Moon. Refined data were obtained to determine the Moon's gravitational field and to construct an accurate theory of the Moon's motion. Luna 5 mission was to test a spacecraft, analog of the Soyuz spacecraft, for a manned flight around the Moon. The spacecraft was the first in the world to orbit the Moon and return to Earth. On board Luna 5, for the first time living beings reached lunar orbit, and also for the first time returned to Earth after circling the Moon. Luna 16, on September 12, 1970, a Proton rocket was launched, which put Luna 16, which included a re-entry vehicle, on a flight path to the Moon. On September 13, by activating the engine of the landing stage for 6.4 seconds, the station's flight trajectory was corrected, which ensured that the station reached the calculated point of near lunar space. On September 17, the Luna 16 station was launched into orbit around the Moon. On September 20th, the Luna 16 station made a soft landing on the Moon in the Sea of Abundance. Then, under control and monitoring from the Earth, the soil intake device of the landing stage was used to collect lunar soil, which was placed in a special hermetically sealed capsule in the re-entry vehicle. On September 21st, the Luna-Earth rocket with the return vehicle of the Automatic Interplanetary Station, LUNA-16, was launched from the surface of the Moon. On September 24th, the station's re-entry vehicle weighing 35 kg was separated from the Luna-Earth rocket and entered the Earth's atmosphere. Lunar soil samples taken in the area of the Sea of Plenty were delivered to Earth. The total mass of the soil column amounted to 101 grams. Luna 16 became the first automatic vehicle to deliver extraterrestrial matter to Earth. November 17, 1970, the first automatic self-propelled lunocod vehicle is delivered to the Moon near the Sea of Rains. In 10 months or 11 lunar days, traveled 10 kilometers over it, conducting a study of the flat terrain south of Rainbow Bay in the Sea of Rains. The estimated time on the Moon was more than triple. More than 200 detailed panoramic images of lunar landscapes were obtained. The mechanical characteristics of the ground at 500 points were studied, and the chemical composition of the ground at dozens of points was studied. LUNA-19 explored near lunar space and telephotographed the Moon. Luna 20 automatically delivered lunar soil to Earth. On February 22, 1972, the Luna 20 station's takeoff stage launched from the surface of the Moon toward Earth. On February 25, 1972, the return stage of the Luna 20 automatic station made a soft landing. A column of lunar soil weighing 55 grams was delivered to Earth. On January 16, 1973, the landing stage of the Luna 21 station delivered the LUNOKHOD-2 automated self-propelled vehicle to the surface of the Moon at the eastern edge of the Sea of Clarity, inside Yoomoney crater. LUNOKHOD-2 operated on the lunar surface from January 18 to May 10, 1973, 5 lunar days. 60 radio communication sessions were conducted with the vehicle, during which operations were carried out to monitor the operation of onboard systems, motion control, scientific experiments, and information was transmitted to Earth. During 5 lunar days, moving in conditions of difficult terrain, the automatic apparatus covered 37 kilometers. With the help of television equipment, 86 panoramas and more than 80,000 television images of the lunar surface were transmitted to Earth. Luna 22, 6th Soviet artificial satellite of the Moon. Study of the Moon's gravitational field, telephotography of the surface. On August 18, 1976, Luna 24 made a soft landing on the Moon in the southeastern region of the Sea of Chryses. 15 minutes after landing, on command from Earth, the soil extraction device was activated. In the process of soil sampling up to a depth of 120 centimeters, the rotary drilling mode was used, and then the drilling mode was changed from rotary to percussive rotary. The total drilling depth was 225 centimeters. Due to the fact that it was carried out with an inclination, the total depth was about 2 meters. On August 19, the takeoff stage of the Luna 24 station with lunar soil samples was launched from the surface of the Moon. On August 22, the descent vehicle landed. A column of lunar soil about 160 centimeters long and weighing 170 grams was delivered to Earth. As a result of analyzing the results of this flight, for the first time there was convincing evidence of the presence